Polynomials and monomials can be multiplied. You may have looked at some of these a little bit earlier when you were multiplying with exponents. When you're multiplying like bases, you add the exponents. When you divide like bases, you would subtract the exponents. For this video, we're just worried about multiplying monomials and polynomials. So in example 1, we're going to multiply the monomial 2m squared times the polynomial of 2m squared plus 3m minus 5. So I'm just going to distribute the 2m. 2 times 2 is 4. M squared times m squared is m to the 4th. Distribute 2m squared times 3m. 2 times 3 is 6. M times m squared is m cubed. And then 2m squared minus 5, or times a negative 5, equals a negative 10m squared. Now, once you've done all the multiplication, you can just verify that there's no like terms left over that you can combine. And in this case, there's no like terms, so that would be my simplified solution. Example 2, we're just to distribute the 6y. So 6y times negative 5 is negative 30y. 6y times negative y is a negative 6y squared. And 6y times 4y squared is a positive 24y cubed. Now, if I want to put this in standard form, I would write it as 24y cubed minus 6y squared minus 30y. Now, if you were to forget to put it in standard form and they didn't ask you to put it in standard form, what I first wrote would be still correct. Example 3. Here, we have a binomial times a binomial. When you have binomial times a binomial, one way of doing it is using the FOIL method, which you can see pictured here. The f's of the first term of each binomial, multiply those, and then you're going to multiply the outer two terms, and then the inner two terms, and then the last one. So first thing I would do is take m times 2m, and I get 2m squared. M times 7 is 7m. Negative 5 times 2m is a negative 10m. And you'll notice where I put that, I put it underneath the 7m because those are like terms and I can combine them at the end. And negative 5 times 7 is a negative 35. Now I can combine like terms by adding straight down, and I get an answer of 2m squared minus 3m minus 35. So when you're subtracting it, don't take out the m. The variable stays the same. You're only adding and subtracting the coefficients. Next example, I have a binomial times a trinomial. So I'm going to use I'm just distributing the 2x with every term of the polynomial and the 4 by every term in there. And then I'll combine like terms at the end. So I have 2x times 2x squared, which will give us 2x to the third. 2x times negative 3 is a negative 6x squared. And then 2x times 4 will give us a positive 8x. Then I distribute the 4. So I have 4 times x squared, which is a positive 4x squared. 4 times negative 3x is a negative 12x. And 4 times 4 is a positive 16. I already grouped all my like terms, so now I just add straight down, and I'm left with 2x cubed minus 2x squared minus 4x plus 16. There's no other like terms I can combine, so that would be my final solution. Next, we'll look at some special products. Special products, you're going to be multiplying them, but there are certain formulas that you can use to make it a little bit easier. Now, you could FOIL all of these if you wanted to, but here with the special products, a binomial times a binomial, so example 5 would be like a difference of two squares. And a difference of two squares, that would be this example here. So I'm going to put a number 5 right here, because it would be looking like this. So if this is my A and this is my B, and this is A plus B, you would just take your A, square it, take your B, square it, and then subtract the two. So here, you'll know you use the difference of two squares because the terms in each of these binomials are the same. The only difference is the sign in the middle. So if I were to use the formula a squared minus b squared, my a is 3p and my b is 4. I now have an answer of 9p squared minus 16. Example 6 is a perfect square trinomial because I have a binomial squared. And you'll notice that this is a plus in here, so I would use this one, number 6. So I would use a squared plus 2ab plus b squared. So again, here's my a, here's my b. So if I write this out, this would be a squared plus 2ab plus b squared. Now this sign right here tells you what sign to start off with in here. And the C is always, this last term is always going to be positive. So now I just have to put the A's in here. So X, X, and my B is 4Y. And now I can simplify it, which will give me X squared plus 8XY plus 16Y squared. Now, if you wanted to use FOIL on this, this is how you would use FOIL. It'd be x plus 4y times x plus 4y. And then you distribute, so that'd be your x squared plus your 4xy. Distribute the 4y, and that gives you your plus 4xy. And then here's your plus 16y squared. Combine it, you get x squared plus 8xy plus 16y squared. See the same answer, it's just one you do a little bit less work for. In example 7, that would be this last one here. The only difference is it's going to be a minus sign in there. So again, here's my A, here's my B. I'm going to do a squared minus 2ab plus your b squared. Now you might wonder why I have a 2 in here. Well, you notice when I did FOIL here, I have 2 of that middle term. So the middle terms are the same and I have 2 of them. So that's why we have that 2 there. So now I put my a's and b's in here. So the a term is 3t squared. And my b is an n. Now make sure you don't put a negative n in here. The negative is already taken care of with this minus sign here. So now I can solve this. 3 squared is 9. T to the 4th. Remember, when you raise a power to a power, you multiply the exponents. Minus 2 times 3 is 6. T squared n plus n squared. And that would be your solution. So that is how you can multiply monomials and polynomials and then using special products to solve.